Thanks, Ron. So today's session is going to be application modernization, the first session of the day. Good morning, everyone. As Ron mentioned, my name is Kunal. I am a senior developer advocate here at AWS. So let's begin here. Okay, so just a little bit about me to calibrate any of the conversations or questions you might have during this presentation or afterwards. Again, I'm a senior developer advocate here at AWS. Essentially, it just means I'm an engineer who builds awareness and adoption of our services. I've worked on a lot of different developer-focused verticals. So if you have any questions on any of those, feel free to reach out to me. The best way to get in touch with me is my Twitter handle at Kunal732. By far, that you get the fastest response. Or you can email me, kbatra@amazon.com. And I'm also really into machine learning and computer vision. We're not going to talk much about that in this presentation, but you can see in that photo on the left over there of the garage door, built-in application lets you know whether the garage door is open or closed. The photo to the right of that is counting how many people are in line at the Shake Shack in Madison Square Park. And then another fun one was just a detection model on some household items I have, just in case I misplace it. So it's a passion of mine. If you want to reach out, want to learn more about that with AWS as well, feel free to email me too, and my email will be at the end as well. All right, so let's begin with this presentation. And I wanted to start this off with this quote from Jeff Bezos. And I feel like it really embodies the message of modern application development. So I'll go ahead and read it, and then we'll just continue on from there. So we want to be a large company that's also an invention machine. We want to combine the extraordinary customer serving capabilities that are enabled by size with the speed of movement, nimbleness, and risk acceptance mentality normally associated with entrepreneurial startups. And this idea of being agile, being able to have rapid innovation, this is a core component of modern application development. So it's not just Amazon. Companies are looking to become more agile so they can innovate and respond to change faster. This requires a different kind of applications than what was common years ago. So applications now need to scale quickly to potentially millions of users, have global availability, manage petabytes, if not exabytes of data, and respond in milliseconds. So there is no exact definition for application modernization or modern application development, but there are a lot of common elements which we'll be discussing in this presentation. So you can see architecture over there. And when we talk about architecture, we're specifically talking about moving towards microservices. When it comes to software delivery, we're talking about how teams are organized around a single service, and each team releases updates independently, getting new features to customers faster. When it comes to data, we're specifically talking about data management, purpose-built databases. So just like a monolithic application, a single database is also difficult to scale. It can become a single point of failure with fault tolerance challenges. So with modern applications, we take advantage of decoupled data stores in which there's a one-to-one mapping of databases and microservice. So it essentially means that for every microservice, we have its own separate database that's the right database for that specific service. And now when it comes to that operations, we're talking about a different operational model for your applications to use as much serverless as possible so you don't have to worry about the undifferentiated heavy lifting when it comes to managing infrastructure. And then with security, we want automated continuous security. So in this presentation, we're going to dive deeper into each of these components. But before we do that, let's talk a little bit about some of the history here we have at Amazon, right? So rewind back years and years ago when we were just a bookstore. We had this giant monolithic bookstore application and a giant database that we used to power Amazon.com. And that really limited our speed and agility. Whenever we wanted to add new features or a product for our customers, for example, like video streaming, we had to edit and rewrite vast amounts of code on an application that we designed specifically for the bookstore, our first product. So this was a long, unwieldy process requiring a lot of coordination, and it really limited our ability to innovate fast and at scale. So during that time, we created a blueprint for change, and this was called a distributed computing manifesto. So this was an internal document, and it described a new architecture. And with this manifesto, we began restructuring our applications into smaller pieces called services that enabled us to scale Amazon dramatically. And to support this new approach to architecture, we started restructuring our organization into small autonomous teams, small enough that we could feed each team with only 2 pizzas. I'm sure you must have heard of the 2 pizza rule we have here. So we were able to innovate for our customers at a much faster rate. And we've gone from deploying dozens of feature deployments each year to millions as Amazon has grown. So we're not alone in this quest to innovate quickly. To remain competitive, companies need to increase their agility so that they can continually uncover new opportunities and create better products. And to really succeed in using application development, modern application development to increase agility and innovation speed, organizations really need to adopt these 5 elements in any order, right? So when we're talking again about architectural patterns, we're really talking about microservices. That operational model is trying to go more into serverless without having to worry about the overhead of infrastructure. Software delivery, we're talking about automated software release pipelines and standardization. For data, we're talking about using purpose-built databases. And then again, for security, automated continuous delivery. So let's start breaking those down. Excuse me. So the first thing we're going to talk about here is that microservice architectural pattern. And this idea of breaking down your monoliths into collections of microservices. So most companies like Amazon, when they start, their businesses, they tend to start with monolithic applications because it's the fastest, easiest system to develop. However, there's a problem with those tightly combining processes and running them as a single service. If one process of the application experiences a spike in demand, the entire architecture has to be scaled up to handle that load of that one process. Moreover, adding and improving features becomes more complex as the code base grows, making it difficult to experiment and implement new ideas. So this is just some of the reasons why microservices start to emerge as companies grow. And with the microservice architecture, applications made up of independent components that run each other's applications processes as a service. So microservices are an organizational and architectural approach to software development. Each service is an independent unit focused on particular business activity. They're managed by a small independent team who's responsible for that one service. That various services communicate through well-defined APIs, but work together to produce a complete system. So again, each team can move independently and simultaneously, which is definitely in contrast to a monolith. And if you start to think about it, this actually sounds like something known as Conway's Law. And if you're not familiar with Conway's Law, it essentially just says your organization design and your technical architecture tend to look very similar. And that's largely due to the communication, the decentralized communication between the services and also how your teams work as well. Other things to note, each unit is small within a microservice, so it can be easily replaced. Distributed work reduces dependencies between different parts. Each microservice can be written in a different language, and each team can choose its own technology stack, whatever is the most convenient for that team. And when we start to think of microservices, we see 3 key design patterns here. The first is API-driven request response applications. And essentially APIs that promise that a team makes to externally to the rest of the organization, but under the hood, it can keep changing. So we've built a lot of microservices here at Amazon, and we've seen a lot of different trends and APIs here. So we created this service called the API Gateway. And the idea with the API Gateway is to take a lot of those lessons that we've learned and provide a lot of those capabilities to our customers. So this often starts with authentication. You can control which customers or other microservices can access the API. It's well integrated with Cognito and our Identity Access Management Service, IAM. It has built-in support for a lot of monitoring and managing tools, X-Ray, CloudWatch, and CloudTrail. So essentially, it's a fully managed service that makes it easy for developers to create, publish, and maintain APIs. And in a little bit, in a couple of slides, I'll showcase a quick demo with API Gateway. So now that second pattern that we see with microservices is our event-driven architectures. And event-driven architectures have this great decoupling ability. It makes it really easy to have lots of different systems that all interact in reactive ways with each other via events. And so we have three services here at AWS that really help power this. We have our simple queue service, our simple notification service, and Event Bridge. So with the simple queue service, SQS, you can transmit any volume of data without losing messaging or requiring other services to always be available. With simple notification service, it's our fully managed pub/sub messaging service that enables you to decouple microservices, distributed systems, and serverless applications. Your publisher system can fan out messages to a large group of subscribers for parallel processing. And then with Event Bridge, it's our serverless event bus that makes it easy to connect applications together using data from your own applications, other SaaS applications, or AWS services. It delivers a stream of real-time data from event sources as well as from Zendesk, Datadog, PagerDuty, and more. And now that third major design pattern that we see takes advantage of streams. So this can be from Amazon DynamoDB streams or Kinesis data streams, and that's how these microservices tend to communicate. So at this point, you're probably noticing that with modern applications, you have a lot of different components that are actually talking to each other. So we've created a service here at AWS called step functions that makes it easy to coordinate the components of distributed applications like these. And this is pretty interesting too, because it's a visual workflow where you can edit this workflow visually as well. So you can take advantage of different services that we have over here and have integrations with step functions, or this can be just a bunch of Lambda functions connected together. And I'll show an example of this as well in that demo portion in a couple of slides. So on the left-hand slide over here, you're seeing step functions that are stacked together in the step function console, right? So each of these red rectangles here represent a Lambda function, and once one completes, then it goes on to the next one. Or you can take advantage of service integrations as well, which as you can see on the right. So essentially, with cloud native architectures, you have these small, loosely joined pieces. And then you also get these design concepts as well. You want to go ahead and use managed services. You don't have to worry about infrastructure. You want to focus in on writing your business logic, so you don't have to worry about, again, managing things that are not necessary for your application. You want to take advantage of loosely coupled and event-driven architectures. And also, again, take advantage of that simplifying delivery that Amazon API, services like Amazon API Gateway can give you. And I'll just showcase two demos right here. So I'm going to go ahead and get out of my presentation. And then I'm going to go to my browser. Can everyone see my browser over here? OK, I'll take that as a yes. I'm going to first go to my console. And I'm going to talk about API Gateway and just showcase how easy it is to create a microservice with Lambda and our API Gateway. So we have this framework here at AWS called Chalice. I'm not sure how many Python developers are here, but it's very similar to Flask. And it's just a really easy way to build out these microservices. So it's really easy to work. It's just like it shows over here. You type in the command Chalice, new dash project, and the name of a project. So in this case, I'll just call it AngelBeat because that's where we're speaking at right now. Going to hit enter, and now it just created the boilerplate code for this new microservice API. And so now I'm just going to go into that directory for AngelBeat, and I can see two files here. The app.py and then the requirements.txt, which just has all the dependencies. So I'm just going to go into app.py and showcase what it looks like. So everything in pink right now, those are just comments with the hashtag and the pink. These are just comments over here, so you can ignore that. But essentially over here, this is our Lambda application. This is just the code we care about. I'm not going to change anything right here, right now. So basically, as soon as I make a request to just the root endpoint, I'm going to get back this object hello world. So let's go ahead and deploy this. Just say chalice deploy, and this will deploy on Lambda. And it's going to do a couple of things. First, it's going to make sure that we have the right identity access management role set up for this. From there, it's going to create that Lambda function on the cloud. In this case, it's going to be called angelbeat-dev. Then it's going to use API gateway and create us an API endpoint to access this. So now it's all done for us. So as soon as I go to this endpoint over here, I'm just going to copy this, switch over to the browser, and then just put it in here. We can see over here, we get back the hello world, right? So really quickly, once you start looking at modern application development, you can see that speed of creating this application, not having to worry about infrastructure, not having to worry about how to create that API and manage it. Just really quickly, we can just within a matter of a couple of minutes, create a quick API over here, right? So this is really rapid, and it really changes that pace of innovation internally for your organization. The other thing I wanted to demo over here too was the step functions that I showed you. And I'm going to demo the step functions with a tool we have here at AWS, and it's called the Media Analysis Solution Demo. So like I mentioned earlier in my presentation, I'm a big fan of computer vision. It's just a passion. It's what I love. And our Media Analysis Solution Demo is just a great way to see all the different aspects of computer vision in AWS. It's already done for you. It's a pre-made application that you can just launch. And this is all microservice driven, right? So the background is just a whole bunch of step functions put together that will analyze a video that you give it. So in this case, I'm going to go ahead and upload a video. And I'm just going to say choose file. And I have this Alexa Super Bowl commercial loaded up from a couple years back. And I'm going to go ahead and upload that video. So now what's happening is it's going to start uploading that video, and it's going to run a whole bunch of Lambda step functions, calling a bunch of different AWS services and checking what labels are it seeing in every frame. Can it detect faces, any celebrities? It's also going to take a look at the audio, and it's going to see what are the captions, convert that into captions, right? So let me showcase an already done version of this, and then I'll showcase the So this is how it looks like. Oh, let me go back really quick. I wanted to show you the step functions, and I just forgot about that. So let me just do it again. Open, pause that, upload. Okay, so now I'm going to show you the step functions of what's happening in the background. It's really small. It's called the visual workflow over here before. Let me just make this a little bigger. Let me just close this. So this is the visual workflow where you're organizing all of your Lambda functions. Very similar to the code I just created before, but obviously has different purposes now. And essentially what's happening is you upload that video, and then it's checking, okay, is it a video or is it just audio? If it is a video, then start running all of these different functions. Everything green is what's being run. It's been succeeded right now. Everything blue is in progress. So you can see it's happening live right here. And it's just running through all of these step functions. And this is something that you can visually put together, right? Again, with microservices, you have a lot of different components here. Sometimes it's nice to have that visual flow to kind of put together an application. But once that's done, you get something like this. So let me go back. Click on browse, and then say, let me go bottom, say view results. And then from here, you can get an idea. It automatically picks up all the different labels of what it saw. It can see all the different celebrities in the video. And these, again, are all from a bunch of different microservices doing all of these different actions. If I press play over here, you can see the captions. on the top. So again, this is just a microservice way of doing things, and step functions helps with that visual aspect of it. So let me switch back to, oh, go ahead.
I can, just two things I just want to emphasize. First is how easy it is for anyone, even a non-programmer like myself, to configure these powerful applications. That's really the power of AWS, and also goes to some of my earlier comments. When you look at your job responsibilities, you don't need to be an in-depth programmer to take advantage of all these capabilities. What's more important, both for your organization and for you as an individual, is understanding these capabilities and then architecting and designing the solution so it provides the max amount of benefit. The other thing why you still need that human intervention, there's obviously, when you look at all these capabilities in visual analytics or video analytics and other solutions, is that there are some privacy concerns, again, to make sure it's done correctly, efficiently, securely, and that's where these tools, everyone needs to understand them. And even if you are, let's say, a traditional systems administrator, network administrator, whatever, you want to look at your job in the future as changing and be able to understand and embracing these capabilities.
Totally agree. All right, so that was the demo, just showcasing some of that. Threw in a little AI in there just because that's the passion. So the next part of the modern applications is having purpose-built databases, right? So modern applications are built with decoupled data stores in which there's a one-to-one mapping of database and microservice rather than just a single database. A single database is a single point of failure, and it's hard for a single database to meet the specific needs of a set of microservices. So by decoupling that data along with microservices, you free yourself to choose the database that best fits your need. So example, as you see over here, some common examples of databases right now that people think of are relational and key value. In this case, for Amazon, that would be RDS and DynamoDB. But you don't necessarily always need relational, right? I know that's something that we hear a lot. Sometimes people think that's the only thing they need. There's a lot of different types of databases that can fit the right tool for the job, right? So we have, based upon what application you have, you can choose different types of databases. So for example, if you run applications that work with a highly connected data sets, such as recommendation engines, you could choose a graph database like Amazon Neptune that stores and navigates these relationships. Or if your applications need real-time access to data, you could choose an in-memory database like Amazon Elasticache, which is commonly used for gaming and IoT apps. In general, the best database is a database that does exactly what your microservice needs, right? So it's no longer one giant database for your monolith or for your multiple microservices. Now you have the ability to choose the right tool for the job. And in this case, you can see over here, the different types of databases internally for Amazon for different types of needs, right? So again, Elasticache was in memory, DocumentDB for document, Graph will be Neptune, QuantumDB will be for ledger databases. All right, so now we'll talk about that operational model when you're talking about modern applications. And in this case, that's moving everything to serverless, right? So modern applications have a lot of moving parts. Rather than just a single application and database, modern application may be composed of thousands of services, each with a purpose-built database and a team releasing new features continuously, right? So you want to be sure that you're focusing on activities that are actually part of your organization's secret sauce and not, again, what's we call undifferentiated heavy lifting. And so moving to serverless really helps you do that, right? So now you can have access to applications. You don't have to worry about infrastructure to provision or manage. It'll automatically scale based on your usage. It's also pay for value billing model, and it will be highly available and durable. And you're going to hear more about this throughout the day. This is broadly talking about these items, but you have different types of compute with serverless, right? You have Lambda, and the primary attribute I would say with Lambda is it is event-driven architecture, right? That's where it works best at. You also have Fargate, which will be great for containers, and there'll be that serverless component for containers. We don't have to worry about managing your infrastructure when it comes to using Fargate with ECS or our Kubernetes service EKS. And so again, just I believe I might have covered this actually in the last Angel Beat session too, and I'm sure you'll hear about this in other sessions today, but we have two different management layers, orchestration services for containers here at Amazon. We have Elastic Container Service. We also have the Elastic Container Service for Kubernetes, right? Both of those, you can go ahead and manage your own infrastructure if you want, or you can take advantage of Fargate where you don't have to manage that as well. So again, when taking a look at in terms of what you're responsible for and what is AWS responsible for, you can kind of see this in this slide over here. When it comes to Lambda, you're just responsible for that application code. Just like I showcased really earlier, that is the simplest way. You just worry about your business logic and you can go ahead and let AWS worry about everything else. When it comes to Fargate, again, worry about your application code, that business logic, and then two other items over here. So essentially with serverless architectures, you have to worry about the business logic, the APIs, and then AWS will take care of everything else. So let's now move on to that next component over here, which is that software delivery, right? When we moved away from our monolithic architecture at Amazon.com and reorganized into the two pizza teams, we stopped using a single release pipeline and began enabling each team to release independently, right? And which is great as rapid innovation, but it also presented a new set of challenges. Maintaining a release process and quality consistency across all the teams, it became difficult, especially when each step of the release process was manual, which added in this human error component as well. So our solution here at Amazon has been two-pronged, right? One, standardization. And so we have this way of making infrastructure as code. And then also automation with CI/CD, right? So first we've defined some software delivery practices for best practice templates. Again, this is our infrastructure as code. Basically, these templates help your teams get started on the right foot. It just gives you the whole technology stack that you can go ahead and provision, right? So essentially, you're just writing your, creating your infrastructure just like you would create your code. Same process, very similar. It's a very declarative way of saying it. You tell it, you just basically go with what you need. And so this makes it repeatable, predictable. You get to use the same exact tools that you would with your code. And it also lets you create that production environment in a staging environment to enable continuous testing. And so this also works for serverless as well. So previously on that demo, I showcased a framework called Chalice, which makes it really easy. We have another framework as well here, and it's called SAM. It's our serverless application model. And this is, it helps you get that infrastructure as code aspect with serverless too. So you get to define things in pretty much a couple of lines of YAML. You can define your Lambda function, your IAM role, the API gateway, and then also your DynamoDB table. And you get to put that down as code as well. Again, this makes it repeatable, and it also makes it predictable as well. And with the YAML, then you can use the CLI tools to go ahead and build and publish that as well. Oh, another really interesting thing I love about the serverless here is we have something that extends the SAM ecosystem, and it's called a serverless application repository. I'm sure you might hear about this later on in the day. This is just a quick overview of it. But essentially it gives you the ability to templatize your applications that you've defined using SAM. And then you get to go ahead and reuse that across your own organization or let other people externally perhaps use that. Essentially, you can just plug in, pick up, and use other developers' code in your application, right? So you can go ahead and kind of templatize or use whatever you need. And then you can just create your own little bit of custom logic on top of that. And then it really just helps rapidly release new software in that way. Also, CI/CD, another big aspect of this. We've seen that a couple of obviously huge things with CI/CD, which helps a rapidly release increasing. It also lowers the failure rate. But the big thing over here is it helps faster. It makes it so much faster from commits to deploys. And in the old days, this was the life cycle, right? So you had a lot of developers focusing in on your monolith over here, and then you had a single delivery pipeline, right? So this thing, it made it really slow. But breaking things apart into a modern application development, now we've split this up. We've created from that massive organization developers into these two pizza teams. Each of these two pizza teams are now focusing in on a single service. This is also giving them the ability to move faster and also innovate specifically for their services as well. And now that last component we talk about is security, right? Basically with our, wait, let me go back. So in modern applications, our security features are built into every component of the application. It's automatically tested and deployed with each release. This means that security is no longer the responsibility of just a security team. It's integrated into every stage of the development lifecycle. Engineering, operations, compliance teams, everyone has a role to play. So we have different security services here that enable you to apply security throughout your entire application, right? We have our identity and access management, which allows you to control users' access to AWS services. You can create and manage users in groups and grant or deny access. For account management, you have AWS Organizations, which offers policy-based management for multiple AWS accounts. Then for a security assessment, we have Amazon Inspector, which will provide automated security assessment services that improve the security and compliance of your applications. We also have Guard Duty, which is a managed threat detection service that gives you a way to continuously monitor and protect your AWS accounts and workloads as well. So that journey to modern applications is still so different for everyone, right? So everyone has a different path to this. A lot of times what we see most commonly is that lift and shift, where it's a rehosting of services from on-premise to the cloud, in this case over here, or perhaps a re-platform from virtual machines to containers. But every journey is different over here, right? Obviously, you have different options available to you. Some of our customers, one is Turner. Obviously, Turner Broadcasting, I'm pretty sure TBS, if people are familiar with it over here. They migrated 850 of their applications in 5,000 containers to Fargate to really take away that extra maintenance of that infrastructure when managing Kubernetes, right? Again, Fargate serverless, you don't have to manage that infrastructure with it. FINRA, the Financial Regulatory Authority, they reduce costs by 50% by taking advantage of serverless and AWS Lambda because they didn't need to run their applications 24/7. They only needed it during certain periods of the day, but by taking advantage of Lambda and its event-driven models, they were able to reduce costs by quite a bit. So just to kind of sum it up over here, so a modern application checklist, right? So make sure to enable security and compliance, structure your apps as a collection of microservices, build with serverless technologies as much as possible, use infrastructure as code, definitely make sure to take advantage of CI/CD, and also use tools like API Gateway to help you with monitoring as well. Thank you, everyone. I hope you enjoyed that. Again, here's my contact info, kbotcher@amazon.com, or you can reach me on Twitter, Kunal732. Please feel free to send me any questions. Thanks, everyone.